All right, good afternoon. Thank you all for coming. My name is Tom Staub. I'm joined here by Douglas McDowell. And hopefully you all know by now we're going to be talking about designing, deploying, and optimizing SQL Server on AWS. If not, it's okay. I understand if you want to leave now and you're in the wrong session. We have a lot to cover, so I'm going to get right into it. I ask you to please hold questions to the end to ensure we can cover everything. Thank you. All right, so first I just want to start with a couple slides to talk about why SQL Server on AWS is such a big topic. This is a study done by IDC that almost 60% of the Windows workloads in public cloud are running on AWS, with barely more than half of that on Azure, and then the rest on all the others. This is only about Windows, but obviously SQL Server primarily running on Windows. You get the idea that it's probably not going to be far off. In terms of AWS specifically, and only talking about Windows and SQL Server, this gives you an idea of the innovations we've made over the past 10 years. And what I love about this is you can see that acceleration, and what you can't see here, but is an integral part of this, is the loop. And that loop I'm referring to is as we innovate, it drives more customers to the platform. And as we get more customers, it drives further innovation, because the customer input is our #1 source of innovation. So in terms of our topic area for this presentation, we're going to start out with designing and optimizing, and then move on to migration, and then on AWS, management and further optimization. For design, these are the six of the critical areas that you're probably going to be looking at, whether it's on premises or on the cloud. Right? These are your critical areas of CPU, RAM, storage, etc., performance. In terms of doing this on AWS, we're going to be talking about two specific services, and that is RDS, Amazon RDS and Amazon EC2. Amazon RDS is our managed service for relational databases, and of course Amazon EC2 is our virtual machine service, not specifically for relational databases, but for anything that you can run on a VM. So we'll start out by talking about RDS. And you can see here a lot of the features that are available on the RDS platform, and a lot of these are not specific to SQL Server, even though that's what we're focusing on today. But as a managed service, we're going to handle the patches for you. We're going to handle updates. We're going to handle backups. We're going to handle high availability. In fact, HA is my favorite part of that because of that last feature I have there, automatic host replacement. So automatic host replacement means that HA is truly hands-off with RDS. So you picture your on-premises environment. If you configure high availability yourself, right? I don't know how many people have done that. Configure maybe always on availability group, failover cluster. When you set that up, let's say you set it up with 2 nodes. You get everything working correctly. What happens if your primary fails? Well, if you did it correctly, you're going to get that failover. You're on your secondary now. That's great. Pat yourself on the back. I did a fantastic job. But now you don't have HA, right? Your primary's gone. Now you have one server. So who has to reestablish HA? You do. You've got to get in there. You've got to get a new machine. If you're on premises, you might have to buy a new machine depending on how bad the failure was. If you're in the cloud, of course, you just spin up a new instance, but you've got to set all that up. With RDS, we're going to do all of that. If that failover occurs to that second instance, if the cause was due to a hardware failure or something critical on that original primary, we're going to rebuild the primary and then rejoin it to the secondary, well, what's now the primary, and reestablish HA without you doing anything. You can literally sleep through the whole thing. So let's compare that to Amazon EC2. Now, the most important thing I want you to remember about when you're looking at RDS versus EC2 is not what one can do versus the other, but who does it. Because I mentioned already that on RDS, we do patches, we do backups, we support high availability. Do you think we don't do that on EC2? Right? If we didn't allow you to back up your database, no one's going to run a database on EC2. Right? I can tell you that right now. You can certainly do that. It's just who's responsible for it. On Amazon EC2, you're taking that responsibility. You're choosing that you want more control. Maybe it's because you just prefer the control. That's understandable. Maybe it's because you want to do something different than what we do on RDS. And we're going to talk about that in a little bit and talk about some of those things that you can do on EC2 today that are not currently available on RDS. One thing that is available on RDS that's not on EC2, at least directly, would be the other engines. I talked about SQL Server, but we do also have that managed server for, or managed service for Oracle, Postgres, MySQL, and MariaDB. But again, it's not directly available on EC2, but you could do it yourself. You could install the products yourself on an EC2 instance. If you choose RDS, you have a couple of instance types to choose from. You can choose an M instance if you want to get the lower cost option, or the R instance, which is going to have roughly double the RAM ratio of the M instances. When I say RAM ratio, I'm talking about the RAM to vCPU ratio. And then for storage, again, you have two options. You have, both are on EBS, which is our elastic block store. You have either GP2, which is sort of considered like the default option that most people will choose, or IO1, which is for your IO-intensive critical workloads. Looking more closely at the instance types, you can see here what I was talking about with the R versus the M, and how the R instances are going to have roughly, almost double the RAM ratio of the M instances for the same CPU count. Also, you can see how the network performance increases as the size increases. So how does all this work? Right? You got to be curious, right? How are we doing all this? So this is how the architecture looks for RDS. It's going to be in one region in multiple availability zones. And that right there is going to stop for a second, just in case anybody here is not familiar with the way we configure availability zones, because I think it's a very important detail to understand. Each availability zone is isolated from every other availability zone, and on a separate floodplain, separate power grid from every other AZ. These are not regions or areas in a building. These are separate buildings that are miles apart. Some availability zones themselves are multiple data centers. So what this means is we're giving you the capability of an automatic failover, but not just to another server in the same data center. We're giving you automatic failover to another server that's miles away. So even if there was a localized disaster in one data center, you have that level of disaster recovery along with that high availability. And again, this is available with all of the engines of RDS, but my favorite feature of RDS is that you don't need to worry about it. It's a managed service. Everything I just talked about, we're going to do for you. All you're going to do is select, I want an RDS instance, I want this instance size, I want this much storage, and I'm going to choose multi-AZ, and we're going to set all that up for you. So how does that compare with EC2? Well, if you tell me you want to run SQL Server on EC2, the first question I might ask you is, how do you want to license that? Because on Amazon EC2, you could choose to bring your own license if you've already purchased a SQL Server license. If you want to include the license with your EC2 instance, that's obviously supported just like it is on RDS, and that's the easier route. If you want to bring your own license, then I have to ask you another question. Do you have software assurance from Microsoft? And whether or not you have that will affect what tenancy model you're able to choose. Once we get past that, then we're back to those same questions with RDS, starting with the instance. But of course, here you see I have a lot more options, right? I talked about M and R before, but here I have a lot more options. Can anybody guess why I would have so many more options on EC2? Because EC2 is not just for databases. RDS is only for relational databases. But on EC2, for instance, you see accelerated computing, you see storage optimized, compute optimized. Right? People are using EC2 instances for just about anything you could imagine you could possibly use a computer for. So we have to have a lot more options. But I highlighted it right there in the middle, the memory optimized, because in my experience, that's what SQL Server wants, right? It wants all the memory you can get, and then I'll take some more, please. So specifically looking at, I chose R5D for this specific example. It's one of those memory optimized instances. These are the sizes available for R5D. And you can see there's a wide range of options here. And you can see, again, it maintains, within a family, it will maintain the same RAM to CPU ratio, but it's going to grow as the size increases, and you're going to get additional EBS performance, additional network performance, and you can see here R5D includes instance store. We're going to talk more about that later, but the instance store size also increases. If this is not enough flexibility for you, if the other screen where you pick the instance and then you pick the size, if you still want even more flexibility, you want even a higher RAM CPU ratio. Maybe I want the whole 768 gigs of RAM, but just for 2 cores. I don't know why you would want to do that, but maybe you do. You could choose the optimized CPU option. You probably don't want to go to the extreme I just mentioned, but it is a very valuable option for less extreme situations like you see here, where you can take an R5 8X large and then tell it to only activate 8 of the vCPUs. This is fantastic for those BYOL scenarios where you want that higher EBS performance, that higher network performance, and more importantly, that higher RAM. But you don't want to have to pay for all those licenses, especially if you're using SQL Server Enterprise. We all know how much that costs. So this is a way to sort of get the best of both worlds. All right, so if you want to do that optimized CPU, you can use the EC2 API or the AWS CLI or the AWS SDK, and here's some of the just small code snippets of how you can do that. All right, so we talked a lot about the compute options, RDS, EC2. Let's talk about storage. I mentioned with RDS, I talked about EBS, and I mentioned also with EC2. Your EC2 instance store and your EBS are going to be the primary ones you're going to be working with SQL Server, and that's why I highlighted them here. They're not the only ones, though. Just to call out a couple of others. Later in this presentation, we're going to talk a little bit about S3 and Glacier specifically as it relates to backup archiving life cycles. And also the Snowball, Snowmobile, those services are great for the migration of your data. But in terms of storing your data files, your log files, that's going to be your instance store and EBS volumes. So what I keep talking about EC2 instance store. What do I mean by that? Well, the instance store is the storage that is actually part of that instance. There's not network attached storage. That's what EBS is. Instance store is actually on the image, so part of the instance. So there are certain benefits to that. It does not have some of the advantages of the EBS, but it does have some of its own advantages. For instance, we're not going to charge you anything extra for the instance store. It's part of the instance. So a lot of people choose to put TempDB on that instance store, right? Also, you have lower latency, especially with certain instance types, and in particular with SQL Server. I point out i3 and R5D. I mentioned R5D earlier. Those both have NVMe local instance store. Super, super fast. You can see here the comparison against EBS. I mean, EBS is fast, but it's not that fast. So if that's what you need that extremely low latency, extremely high IOPS, 3 million IOPS as it shows here, you could do that with that instance store. I do recommend, if you want to use instance store for more than temporary storage like tempdb, if you want to put your main data or log files on there, I highly recommend that you do set up some sort of redundancy. Maybe through availability groups or however, failover cluster, whatever you want to do, but somehow set up something so that's not your only location. With Instance Store, if the instance is stopped, not if it's restarted. Restart, you're fine. But if it is actually stopped, you will lose that Instance Store. On a restart, you're perfectly fine. EBS, on the other hand, you're not going to lose it. You can stop, you can restart, whatever. In fact, you can move the EBS volume to a different EC2 instance. It's one of the things I love about EBS. The other thing I love about EBS is it is inherently redundant. I'm going to say that again. EBS is inherently redundant. Every volume you ever create on EBS is automatically redundant without you doing anything. There's no checkbox. You can't not do this. It's automatically that way. The other thing is encryption. Right? You could set up your own encryption. You could come up with something for the Instance Store. But with EBS, it's just a matter of saying, oh, yeah, I'd like to encrypt that. And then you indicate how you want to do that. The encryption is a great feature I love because, of course, SQL Server includes encryption, right? We all know about transparent data encryption. And we all know what about that? It requires Enterprise Edition. And, of course, that's, 3 times the cost of Standard Edition. With this, you don't need TDE. What you can do instead is you can encrypt the entire EBS volume. And then I do strongly recommend you remember to encrypt your backups if you're moving your backups to S3. But you encrypt your volume, you encrypt your backups, and you have that encryption at rest that you wanted, but you didn't have to pay for Enterprise Edition. So here's a look at the different volume types for EBS. I mentioned GP2 and IO1 earlier. Like I said, GP2 is sort of the default that people typically would choose. If you have those IO-intensive critical workloads, that's where IO1 comes into play. Generally, what you want to remember is that GP2 volumes will deliver within 10% of the provisioned IOPS 99% of the time. IO1 volumes will deliver that same performance 99.9% of the time. So for those applications that have a very low fault tolerance, they need that critical performance, that's where you want to go with IO1. SC1 on the far right here, I don't really talk about much with SQL Server. That's more your cold storage. But ST1 does come into play. ST1 is a throughput optimized HDD, whereas the first two on the left are SSD. So I don't recommend the data and the files data and log files on ST1, but it is a great option for backups because you don't have as high IOPS with that, just by the nature of the physical drive, but you do have that throughput performance. So of course, backups being more of a sequential operation, it works really well with that. If you're using a native backup tool, a lot of people go that route. You can, of course, there are ways to back up directly to S3. But if you're backing up to EBS, I strongly recommend you look at ST1 because you can see here, these are pretty recent prices. You can see here, even compared to GP2, it's less than half the cost. That's the important thing to remember, whether it's RDS, EC2, the different EBS volumes, the different volumes of EC2, everything's purpose-built. So nothing's bad, nothing's good, it's all good for a specific use case. Okay, so in terms of optimizing performance on EBS specifically, the takeaway here is that you can't look at just EBS you can't just look at EBS by itself. And you don't want to look at just EC2 by itself. I talked about EC2 earlier in terms of increasing the size and the EBS performance that it's capable of. But that's exactly it. It's capable of that. And EBS is capable of a certain performance level. But both are going to vary depending on the size of the EBS volume, the size of the EC2 instance, and it's the cross between the two. So you can see here, what I've done is I've taken an X1E instance, which is fabulous for having even a higher RAM ratio than the R instances, and I coupled it with a 2 terabyte EBS volume, and you can see my IOPS are fine, but the throughput is not going to be what I thought it was going to be if I was looking at my EBS volume. I'm going to think, wait a second, I didn't get the full 160. If I go with the larger, with the R5 instance, I don't have as much RAM as I had on the X1E, but I have more than enough EBS performance. So in this case, the marks on the left are indicating specifically in terms of EBS performance which one's better, but obviously which one's better is going to pertain to your workload. If the RAMs are more important than the performance, or maybe you want to increase it a different way, and there's so many different variables. And then there's RAID, right? Even more variables. So certainly, how many people have ever configured a software RAID? I know more people that did not raise their hand have also done it. You're just shy, that's okay. You can configure those software RAIDs on EBS. The one thing I'm going to ask you, please do not do when you configure RAID on EBS is do not mirror the drives, because EBS is inherently redundant. You don't want redundant. It sounds bad even. Okay, high availability, disaster recovery, right? Those are all great topics. We love talking about that. Wait, did I show this slide before? No, I didn't show the slide. This looks a lot like that RDS slide, though, doesn't it? This is EC2 high availability. This is an always-on availability group. Very similar to the way we talked about with RDS. Multi-AZ, single region, synchronous commit, automatic failover. Same setup. Of course, now, like I said, in this case, you're managing it yourself. You're setting it up yourself. What if you say, you know what, that's great, I could have done that with RDS. I chose to do it myself because I don't want to just do 2 AZs in a single region. I want a readable secondary on the other side of the country. All right, no problem. I'll set that up for you. We'll set up a second region. Now, in that second region, we're going to do a manual failover, asynchronous commit. I don't recommend that synchronous commit with that distance, but between availability zones, absolutely, I do recommend that synchronous commit. You won't have a problem there. Another way to go, I don't know if you're familiar with distributed availability groups. This is a somewhat newer feature. This is where you join 2 different availability groups, bridge them together into one distributed AG. I'm showing this here now. We're going to talk about this more later for a specific use case. And finally, one of my favorite HA options is the failover cluster. I know, this is old school. Anybody still doing failover clusters? A couple people? I'll tell you why I love failover clusters. Because that scenario right there does not require Enterprise Edition. And in 2016, SP1, just to remind everybody, Microsoft changed the rules on licensing with SQL Server. They said, you know what? Transparent data encryption, full availability groups, yeah, we're still going to require Enterprise Edition for those things. But if you want to do data compression, you need to do table partitioning, column store indexes, a couple other features. We're going to make all that available in Standard Edition now. So as soon as they said that, I said, well, then I'm going to be pushing this a lot. Because I know customers that were choosing Enterprise Edition just to get those features. Now, as long as you're okay with the memory limitations, the core limitations for Standard Edition, I can give you, remember, this is multiple availability zones. This is a multi-data center automatic failover, but with SQL Server Standard. Okay, so we talked a lot about the compute instances, the storage instances, all on AWS. You might be thinking, well, that's great. I hope you're thinking that's great. I hope you're gaining a lot from this. But maybe you don't know how to get to AWS. So that's what we're going to talk about now. I always recommend keep things simple, right? No point in overcomplicating things. Sure, we're all familiar with applications that need to be up 24/7, but we're also all familiar with applications that don't, right? I tell people all the time, decisions are not company-wide, right? It's everything, it's case-by-case basis. If you have those applications that can afford a little downtime, this is a really easy solution. You just do a backup, transfer it over. If it's huge, sure, go ahead and use Snowball or Snowmobile even. If it's smaller, maybe you just want to upload it. put it on, you can upload to S3, for instance, get it set up for RDS or EC2, and you're up and running. If that's not going to work out for you, say, oh, I can't afford that downtime. In fact, I can't afford downtime, which is why I have an availability group running on premises, to make sure I don't have any downtime. Okay, fine, you have an availability group, that's great. Because remember I talked about distributed availability groups? Well, here's that use case I was talking about. So we're going to take your AG on premises. I'll say build another one. Build another AG on EC2 on AWS. And I'm sorry, I forgot to mention this earlier, but this image you see here on the right, that single region availability group, you know what's the easiest way to do that? You just run our quick start. We have a quick start. You can look it up online. There's a SQL Server quick start that will do this exact scenario here. We can actually create 3 nodes if you want, but you can create 2 or 3 nodes and 2 or 3 availability zones, set up the AG for you. What this does is we're going to say, okay, you know what? Take your availability group on premises, take your availability group or build one on AWS, and then join them as a distributed AG. Once you have that set up, then you go through the steps to perform a manual failover to AWS when you're ready to make that move, and guess what? You're on AWS, no downtime. If you don't have availability group set up, if you're not comfortable with the distributed AG, you can't have that downtime, you want something else, we've got an app for that, right? You hear that all the time, right? We got a service for that. We have the database migration service. As the name implies, it's for migrations, but it's not specifically for migrations. It actually can also be used for continuous replication of your data. And it works very well with our schema conversion tool, which enables heterogeneous migrations. So what's that mean? Well, we could do a rehosting of your SQL Server data over to Amazon EC2, like we talked about. We could do a replatform over to RDS SQL Server, or you could actually refactor to one of the other MySQL or Postgres on RDS. You could, depending on what you're doing, if it's more of a warehouse scenario, you might want to migrate to Redshift. So we have several options there. And then finally, if you're running VMware on premises, we do have VMware Cloud on AWS, and that's certainly another option that you're going to want to look into. Okay, so now we're on AWS. We did the migration, we're there, we got it all set up, we picked our landing zone, we migrated the data. Now what? Now we just let it go, right? It'll be fine, right? Just like on premises, right, no. You always want to keep an eye on it, and you want to continue optimizing and making sure that it's running to optimal efficiency. AWS autoscaling is a service that is most often talked about in terms of scaling, like the name says. In terms of that horizontal scaling, if I suddenly have an increase in my load and I need to scale out and add more servers, and I can scale back if they're not needed, and getting that elasticity, and that's great. But another use case for autoscaling that I've seen quite a few customers use is not to scale out, but just to make sure that I don't lose a server. So let's say you're on EC2, you set up an availability group. You have that multi-AZ availability group, failover occurs and fails over to the second AZ. And the failover occurred because there was a failure of that first EC2 instance. You can have an autoscaling group set up that says, oh, you know what? I need to recreate that first EC2 instance. Now, this isn't quite like automatic host replacement because, first of all, you're configuring it yourself, but that's fine. You're going to configure autoscaling. Not that big of a deal. Not that difficult. But you do now need to configure getting it back into the availability group, right? Reestablishing that. That can be automated, or you could do it manually. But either way, you're going to be doing that part yourself. As opposed to RDS, where again, it's going to do all that for you. Systems Manager. I'd love to talk about this more, but honestly, there are entire presentations just about Systems Manager. But it's a fantastic service. You can get inventory information, compliance information, patch management, all of this. It works with instances on AWS. You can use it for on premises, I highly recommend, if you haven't looked at it yet, look into AWS Systems Manager. And then CloudWatch. I really hope anybody in here who is already using AWS is using CloudWatch. This is sort of our ubiquitous monitoring tool. I just threw a couple things up here as an example of some of the things you can monitor with EC2. If you're using RDS, of course, since that's a managed service, we have more information. Here's an example of what CloudWatch can provide for RDS. But CloudWatch is exactly that. It's a monitoring tool. It's going to be able to tell you, oh, hey, you've got a lot more database connections. Well, why? What happened? What was going on? Or, maybe the IOPS suddenly, fluctuated, or CPU, the CPU utilization suddenly shot up. Well, why? What's happening underneath the covers? Well, that's where I'm going to ask Douglas to come on and talk about how SentryOne can help you get some of those answers. Douglas?
Excellent, thanks. So this is a partner session, so I'm honored to be invited as a partner. We've actually been, at SentryOne, been working with the AWS and the RDS on SQL Server team specifically over the last year around our offerings. And so I want to tell you about 3 different things that will help you take ownership of your SQL Server on AWS. Plan Explorer, SQL Sentry, and Doc Express. Plan Explorer, start with that because it's free. It's something you guys should be using in your daily life for query optimization. Talked to Microsoft's engineering a couple times in the past few weeks, and I always ask them, what are you going to do that's in our space? And they said, we would never do anything like Plan Explorer because you guys are doing such a good job of that, and it's free. Why would we go build something that folks can come and get? But if you're looking at your query plans, it's going to show you everything that's going on around it. What indexes are being used and whether they're optimized for that query. Looking at the statistics that are going on during the query. And you can actually do a playback around the estimated plan and or the actual plan if you want to go ahead and run it. And you can share those around if you have multiple developers or DBAs that are using the tool to do your development work. And it keeps track of the history there. And then there's a really good interface for if you're trying to diagnose what's going on with deadlocks. So that's Plan Explorer. Hundreds of thousands of folks use it already. Go get it. It's free. Yeah, we used to charge for it, but we made it free a few years ago, and people love it. The next one is SQL Sentry, and SQL Sentry, of course, is full support for EC2 as well as for RDS. And this is your database monitoring for SQL Server. And so that's when you want to go that layer deeper than what you're going to get with what SQL Server includes themselves, as well as what AWS has. And it's going to let you look at weights and queues, and then move through and do root cause diagnostics and diagnosis of what's going on with any performance problems you have, as well as alerting surrounding that. And you can do baselines as well. It's really helpful for when you're doing those migrations because, as Tom was saying, there's a bunch of different options to move your data to the cloud, but most of the risk goes on around that process. And am I sizing it right? Will it perform well? What was my performance before and after? The baseline's capability is critical for that so that you can do optimization of that workload, look at what your baselines are, and then once it gets to the cloud, you have operational ownership of it there and can look at that instance from, once you cloud lifted that. You may want to be interested in what all this looks like. This is, if you just go into our high-level enterprise health overview dashboard, you'll see something like this. And what's important is the numbers up at the top and what we call wedgets. And it just gives you a health score of your whole data estate. Now, this is regardless of where it's living. You could have your on-premises as well as your AWS. And if you if you're eagle-eyed there, you can see over there, there's a RDS instance that's running. And going back here, if you have anything going on, those lines underneath the visualization there is going to tell you which servers are causing the problems. And then you can click into those. So if you did click into, for instance, this RDS instance, you're going to get a purpose-built dashboard that's going to show you a lot more than what you're going to get in generic monitoring capabilities from AWS or from Microsoft. And you can see all the different areas of that SQL instance that you can see what activity is happening. This updates about every 10 seconds, doesn't use an agent. It pulls those instances and brings that back. And of course, if you're interested in something, you can highlight it, and it's going to highlight it everywhere on all the different graphs. And then, hey, what do I do about that? You can right-click. You can choose to zoom in on it. Of course, this is capturing history, so you can roll back what happened yesterday at or last Thursday at a given time, because you always get the complaints afterwards. Hey, I had a hard time getting my report, or it was really slow during a certain window. So you can go back in time and look at that, highlight it, and then choose what to do with it. My favorite view is top SQL, because if you just go right into whatever you've scoped it with, it's going to take you right to the list of most egregious SQL that was running at that time. It's captured all that, and then you can go through and select each one of those and see what's happening. Now, this is really important because often one of the things that we overlook or can't get our arms around is one of those little stored procedures that may run thousands of times in a given hour or even in a couple minutes. And by itself, it runs really quick, but it's kind of death by 1,000 cuts, because it just keeps that stored procedure itself is actually creating a whole bunch of bottlenecks, and if you can diagnose that. So what you're looking at here is that for a given query statement, it's actually showing the query plan use. So the query plan changed at some point. That's why there's two different colors there. And each one of these dots is actually an execution of that query plan. And if you hover over one of those, it's going to tell you exactly what's happened. And then you actually have the plan diagram up there. And so we're moving back into Plan Explorer space, because then you can just open that and go right into Plan Explorer, the free tool I started with, and see what happened there. Of course, the big difference there is that Plan Explorer is for when you know what query you're going to optimize. And then, of course, SQL Sentry is owning your overall environment and then being able to do that top floor to all the way down to the query plan optimization. The other thing I wanted to tell you about is Doc Express, because how many of you guys are partners like systems integrators? A few of you. And then anybody that's responsible for your environment. The worst thing, the biggest gap I usually find around systems is that people don't have good documentation. And Doc Express is a push-button documentation capability. So whether you're a consultant doing an engagement or whether you own your environment, then being able to capture your documentation is critical, and keep it up to date all the time. You can automate the generation of documentation. So it's going to create documentation for you, whatever format you want: compiled help file, HTML, Word document. And then you can customize it to a given template if you want to for internal standards. And this is good for not just technical folks, but also for business users, because you have to supply a data dictionary for business users. The really cool thing is lineage and impact analysis. If you screw with something, what's going to break other places? Or if you're tracking data, I've had a bunch of clients that were concerned about GDPR, tongue-tied today, and looking at personally identifiable information. Where is that in my environment? Well, you can actually tag it and then look at the lineage that social security number starts in that relational database. It goes through that integration services package, and those stored procedures over there ends up in that data warehouse, then goes to that cube, then goes to that reporting services report or that Tableau report, and it will see all of that and help you keep track of that. And then you can build that data dictionary and actually annotate it. This is the business user. This is the SLA for that. This is personally identifiable information. And then every time that you push the button on your build in your DevOps pipeline, you should add the documentation generation. So then you have a snapshot of documentation, and then you can do differentials. The best thing is like if you're a consultant, you go and you build something, and then 3 weeks later the customer calls you and says, it broke. You say, great, push the button, send me your documentation. Oh, you remove that column and that index is gone. It's definitely going to break. So you can have that visibility because this is all taken care of. Again, no one likes to do documentation, but it's one of your biggest liabilities if you don't have it, and can really be value added, especially if you face it back out to the end users. That's what I was going to show you. I'm sure you have questions for Tom, all the configurations he showed you.
Yeah, so we're going to answer some questions at the end. Before we do, I just want to thank Douglas for being up here.
Thank you.
And I want to talk about a couple of programs that we have available to help you get started. These are some of the programs available to customers. Several of these, as you can see, it describes here, these are partner-led. Anytime I'm dealing with a partner-led program like this, anytime I'm talking to a customer, they say, you know, I'd really like some more expertise to help me with this. Do you have any partners you recommend? I say, absolutely. Because one of the things we do with AWS, we have competency programs. And we have a Microsoft competency. And these are our Microsoft competency partners. If you're looking for a consulting partner, these are the consulting. I can see SentryOne on here. These are consulting partners. But if you're looking for a consulting partner to help you, whether it's using SentryOne tools, using other tools on AWS, these are the partners that we've audited, that we've worked with. There are public case studies you can look at to see what they've done for other customers. And then finally, here's some helpful resources. If you have more information you want to look up, this is all information publicly available online, as well as additional information for training. And with that, thank you very much. On behalf of myself and Douglas, thank you for attending the session. And please don't forget to fill out the survey at the end.